Okay, the last section in chapter 8 is linear inequalities in two variables. So the situation here is you end up graphing the line as if it were an equal sign, and we'll end up shading one side or the other. The reason for that is basically when we have less than or equal to in two variables, they depend on each other, and so the moment we have the line, it tells you that one side of these is going to be a solution and the other side is not. One thing to note though, if you have a less than or equal to or greater than or equal to line, you'll graph the line like normal. But if you have a less than or greater than sign, you'll graph a dashed or dotted line. And we'll talk about different strategies for shading, knowing which side to shade or not on the line. One strategy is to choose a test point. 0, 0 is usually the easiest one, and plug it in and see if it works. If it does work, then all the points on that side work. The other is the concept of knowing which side of the line is less than and greater than, which I call kind of the coin drop trick. Okay, but first let's just talk about the inequality symbols that come from word problems. Identify the inequality symbol for the bold-faced words in the following statements. It's all bold, but in general. The number of motor vehicles in the U.S. in 2009 was 3,615, less than the number in 2018. So that's just a straight less than symbol. So you'll have to potentially convert some words into equations. As of January 2012, the usage charge on many of the AT&T calling plans was at least $9.99 per month. That means greater than or equal to when it says at least. It's important to be able to turn the words into the right symbols in word problems. Now, there's more true or false questions in this section like there have been in previous ones. Decide whether the point 40 lies on the graph. 3x minus 4y is less than 12. Again, you'll plug in and see if the inequality holds true. 3 times 4 minus 4 times 0 less than 12. It's 12 minus 0 less than 12. So is 12 less than 12? Technically, no. Even though 12 is equal to 12, it is not less than 12. So this is false. When graphing the linear inequality, 3x plus 2y is less than 12, use the dashed line for the boundary line. This is true. As long as there's no equal to sign, you will always use a dashed or dotted line. Okay, so graph each linear inequality and then shade appropriately. So x plus y is less than 5. And move the x to the other side. Y is less than or equal to negative x plus 5. So that's a starting point of 5. A slope of negative 1. Now, because this is a less than or equal to sign, I will graph my line normally. So again, there are two options for determining which side of this line I'm going to shade. One, plug in a point. The easiest point is 0, 0. So you can plug in 0, 0 every single time, except for if 0, 0 is on the line in the middle. You can't plug in a point on the line. So we're going to plug in 0, 0. Is 0 less than negative 0 plus 5? Well, is 0 less than or equal to 5? Yes. Which means we'll shade the area that 0, 0 is in. 0, 0 is in this area on the line, or below it. Now, what is your other option? I call it the coin trick. Okay. So we're looking for all of the areas that are less than this line. So sometimes it's hard to tell whether something's less than or not. The reason I call it the coin trick is I say, take a coin in the region, so either up here or down here, and drop the coin. If the coin would land on top of the line or have to pass through the line, then you are above the line. If the coin, say dropped from over here, goes below the line, then you are below the line or less than the line. And then you can look at the inequality. I want less than, so I want the area where the coin doesn't cross the line, which is the same area that the 0, 0 is in. You can use either one of these if you want. You just have to be careful that you're doing it correctly. We'll leave number 4. Let's do number 5. Y is greater than 4x. So here we've got the line going through the center, 0, 0, slope of 4. Now, both of our tricks for testing sides are harder on this kind of problem because I can't plug in 0, 0, so I have to pick a different point. So pick one that's easy, like, let's say 1, 0, because 0, 0 is on the line, so we can't use it. Is 0 greater than or equal to 4 times 1? So 0 greater than or equal to 4? No. So 1, 0 is on the right side, but it didn't work, so I would shade the left side. If you do the coin trick, technically if you drop a coin on this right side, it goes down, but the line is going to the left, so it's not going to land on the line. If I drop a coin on this left side, eventually it will hit the line. It may take a while, but it will. So that's how the coin trick works there. Really, there's just some more of these. X is greater than or equal to -2. Remember, x equals lines are just vertical lines, so we go to -2. Here we're going to do a full line. Where x value is greater than -2, to the right. So this is one of the ones that coin trick doesn't work, but you can know that greater than or less than for x, greater than is always to the right, less than is always to the left. Y is less than 5. Y equals lines are horizontal lines. Because it's less than, this is where we use the dotted or dashed line. So it looks like this instead. Now it's above or below, less than for y, it's below. So for the x and y equals lines, or greater than or equal to lines, you can usually use this as a strategy. So now let's do number 8. 2x plus 6 is greater than -3y. If I want to get y by itself, I'm going to rewrite this real quick. -3y is less than 2x plus 6. Just I want my y on the left. When I divide by -3, I have to remember that multiplying or dividing by a negative in an inequality flips the direction of the inequality. So now this is y is greater than -2/3 x minus 2. So I've got my line that I've got to graph. So I start at -2. Slope of down 2 over 3. Okay, it's only a greater than or less than, so I have to graph it as a dotted line. On your homework, there's a dotted line option. Just make sure to click it when you're graphing the line, and it will automatically be a dotted line. Now, I'm looking at the direction of the inequality when I'm done, if I'm going to use the coin trick, or plug in. You can also do it at the beginning, you just have to be careful. Let's plug in 0, 0. Is 0 greater than -2/3 times 0 minus 2? Well, 0 greater than -2? Yes, which means 0, 0 is in the solution, which is here, so I will shade above the line. Lastly, let's do number 10. 3x minus 2y is greater than 6. So -2y is greater than -3x plus 6. Divide by -2. Remember again, changes direction. Y is less than 3/2 x minus 3. So I graph y equals 3/2 x minus 3. So we start at -3. Rise over run, 3 over 2. Up 3 over 2. Down 3 to the left 2. From here again, it's only a less than, so dotted line. And now it's about shading the right side of the graph. Less than usually means it's going to be under the line. Now if I do the coin trick, that's to the right, but let's make sure. That means 0, 0 shouldn't work. Is 0 less than 3/2 times 0 minus 3? Well, 0 less than -3? No. So I don't shade the side with 0, 0, which means I shade the other side, just like the coin trick would have told us. And that is all for 8.4 and Chapter 8, and that is the last material for this next test.